Today we are going to learn about the concept called stress strain profile graph. The graph is drawn between the stress and strain. Strain is taken along the x-axis and the stress is taken along y-axis. Now we are going to see how the variation occurs between the stress and strain. What will happen if stress is applied? What is the corresponding change in the strain? The relationship between stress and strain that could be analyzed here. By using this graph, we are able to analyze the elastic characteristics of the object, elastic characteristics of the wire. Okay, we know about Hooke's law. As per Hooke's law, we can say that stress is directly proportional to strain, or we can say that strain is also directly proportional to stress. In both forms we can say. We know about the Hooke's law statement. Within the elastic limit, stress is directly proportional to strain. That is a statement given in the Hooke's law. Here I am going to demonstrate a demonstration here. Look at that. Here, now let us take a spring like this. So in this spring, no load is added. If no load is added means no stress is acting on the spring. Are you clear? When stress is given to this by adding the load, what will happen? The spring or the wire that is stressed. By adding the load alone, we are able to increase the stress value. Now I am going to add 150 gram weight. After adding the 50 gram weight, look at that spring is elongated. After adding the load, it is stressed. Because of that, there is a change in the shape of the spring. It is elongated. So strain is produced within the spring. Are you clear? Note down the reading here. This is the marking at which that load is there. Now I am going to add the load. Now the total load is 100 gram. Because of the addition of one more 50 gram, the total weight is how much? 100 gram. After adding the 100 gram, what happens? The stress is more. When the stress is more, strain will also be more. Are you clear? Now I am going to add one more 50 gram. Now the total weight is 150 gram. More stress is given to this spring and the spring is more strained. Strain is also more. Are you clear? Look at the marking here. Now I am going to add one more 50 gram. The total weight is 200 gram. More stress is given to the spring and it is strained more. The strain within the spring is more. Note down the reading here. Now furthermore 50 gram is added. After adding 50 more gram, total weight is 250. Since more load is added, the stress given to the spring is more, strain is also more. Are you clear? I am going to add one more 50 gram. After adding one more 50 gram, the total weight is 300 grams. More amount of stress is given to the spring and more strain is created. So if you going on adding load one by one, when more stress is given, proportionately strain will also be given. Are you clear? So if you measure it and tabulate it, you will get a straight line. Are you clear? The stress value and strain value, if both are tabulated, if all points are marked, you will get a straight line. Are you clear? So if you get the straight line means it shows that when stress is increased, correspondingly the strain will also be increased. Here initially 50 gram was added. When 50 gram is added, stress is less, strain will also be less. Are you clear? When 100 gram is added, strain will be more. So correspondingly, when stress is increased, strain also increases and you will get a straight line graph. Are you clear? So in this region, that Hooke's law is obeyed. When the stress is increased, strain also proportionately increased. Therefore, in this region, the Hooke's law is obeyed. So here right from O up to A, the Hooke's law is obeyed. So we have moved from the clear O to A. Are you clear? Just we have to check it up whether the Hooke's law is obeyed or not. How to check it? Now what we have to do? We have to remove the loads one by one. Now I am going to remove the loads one by one. We will check it up whether the thing is obeying Hooke's law or not. After unloading, look at that. Again it has come back to the same position. Are you clear? If one more load is removed, what happens? It has come back to the same position. Now if this 50 gram, final 50 gram is removed, finally it has come back to the same position. So it shows that the length of the spring is not altered. If it comes back to the original form, it shows that it obeys Hooke's law. Are you clear? Now, clear. Because of, since it has come back to the same position, we are saying that clear this demonstration, in this clear the graph that shows that the material clear, even though it is subjected for stress and the corresponding variation in the strain is noted in this region, it shows that it obeys Hooke's law. Are you clear? While loading, the graph to be drawn in this direction. While unloading, what will happen? The plotted values, it will come back to 0. Are you clear? While loading, the graph it is to be drawn in this direction. While unloading, the points they will be coming one by one. Finally, it will be reaching 0. It shows that it obeys Hooke's law. Are you clear? So here, this is the point called A, where that is the final position. That final position of the straight line is called A. That is called as limit of proportionality. Limit of proportionality means that is the end point where the Hooke's law is almost clear. It comes to that end, beyond which these two never be proportional to one another. That's why this is called limit of proportionality. If you draw the slope in this particular straight line graph, you will get the ratio. Are you clear? You will get the slope. How will you calculate the slope? In general, the slope is called m. Usually, what is the formula for slope? Slope is equal to dy by dx. In y-axis, which one is taken? Stress is taken. So, therefore, slope is equal to stress by the corresponding variation that is seen in the x-axis. There will be getting the strain. Look at that. This one, that difference that gives you the stress, this difference that gives the strain. So, stress is there, here strain is there. Are you clear? So, if you calculate the difference in stress and strain, you will get the slope value. Are you clear? That slope value that gives a new quantity called, what is this? Young's modulus. Are you clear? So, since it is obeying, in this region it is obeying the Hooke's law, there only you are able to draw the slope. From this we are able to get the Young's modulus of the spring. Are you clear? So, this is the region in which the Hooke's law is obeyed, beyond which Hooke's law never be obeyed. Okay, that is going to be seen in the next concept. Okay. Now, we are going to see what happens in the portion AB. Are you clear? We are going to analyze what is going to happen between the stress and strain in the portion AB. Here, look at the same arrangement. Here, almost maximum load is added here. If furthermore load is added, what will happen? If one more 50 gram is added, then the stress will be increased in a very small amount. If one more 50 gram is added, what will happen? The stress will be increased by very small amount. But the strain is more. Are you clear? If little amount of stress, that one causes the greater variation in the strain. Therefore, the graph slowly it starts inclining. Are you clear? The graph it's slowly inclining. Instead of drawing in the straight line graph, the graph is slowly declined. Are you clear? So, stress is less, but the strain will be more. It reaches the point B. Are you clear? So, that point is called yield point. Are you clear? The point B is called yield point. And one more thing is, if all loads are removed, again it will be reaching the same length. Are you clear? Though if all loads are removed one by one from the experimental arrangement, so clear what will happen? It will be going back to the same normal condition. So, up to this, within the elastic limit, the body is there. But in this region, the Hooke's law is not obeyed. That you have to understand. In between the region A and B, the Hooke's law is not obeyed. That is very important one. Are you clear? Hooke's law is not obeyed in this region because it is not a straight line, but it may come back to the same position. Are you clear? So, this point B is called yield point. If you extend the line from B, there you mark it, there you will be getting the maximum stress. That maximum stress is called elastic limit. Within the elastic limit, clear that body is there. That is a point called B is called yield point. But Hooke's law is not obeyed. Understood? That is very important. Are you clear? Now we are going to analyze what is happening in the portion CD. Okay. So if furthermore stress is given to the object, what happens? Suddenly the strain increases. If stress increases, suddenly the strain increases. Even after the removal of the load, strain increases rapidly. It reaches the maximum point. That maximum point is called D, at which the maximum stress is created. That maximum stress is called breaking stress. Are you clear? When it reaches the point D, when maximum stress is given, breaking stress is given, what will happen? The wire, it starts breaking. That breaking, initial breaking occurs, no, that is called fracture point. So that fracture point is seen at D. Are you clear? If furthermore it's clear possibility is there, what will happen beyond D? What will happen? The wire, it is broken. Are you clear? So at point E. So when the point E reaches, the wire is broken.